We are working on problem 8.32, and for this we need to find Vt for when t is greater than 0. Against the time domain with the step function, we have here is a current source, a voltage source, capacitor, inductor, and 2 resistors. Now for the time domain, we're going to first do for when t is less than 0, and you should recall from a step function that u of t equals 0, but because right here we have a negative t, so that flips it, so it becomes a 1. And for this, when t is 0, the voltage source is short circuited, it's turned off, and our current source is turned on. So we have voltage source is a short circuit. When t is less than 0, capacitors act as an open circuit and inductors as a short circuit. So the redrawn circuit looks like this. So this is the voltage over the capacitor when t is less than 0. We have the 3 amp source, and we have the 2 plus 4 ohm resistors in series. We have 6 ohms. So I of 0 minus is just 0 amps because there's an open source. There's an open circuit here, so no current can actually complete. So that is just 0 amps. For V0, it's the voltage would just be negative 3 V, this Ohm's law right here, so current times resistance, so just 3 times 6. It's negative 3 because as you can see here, the I goes this way and the current source goes this way, so it goes against each other. Or you can look at it this way. This is the negative side and this is the positive side, so it's just the opposite. So 3 times 6, negative 18 volts. Now we're going to go to time domain when t is greater than 0. When t is greater than 0, the current source is an open circuit, and u of t, because u of t is 1, so now we have the voltage source that's active and the current source is inactive. So when that happens, the current source is an open circuit. Now we have to find these two values. So these equations are given for you. So first one is R over 2L, which is just the resistance, so it's 6. 2 times the inductor, which is 1 Henry, it's just 3 radians per second. And we have 1 over square root of LC, which is 1 over square root 1 times the 0.04 farads, which just gets you 5 radians per second. So once you have that, then you have to check to see if it is overdamped, underdamped, or critically damped. And with this formula, we get negative 3 plus minus square root of 9 minus 25, which gets you negative 16. Negative 1 is just j, which is an imaginary number, so it just becomes negative 3 plus minus j4. And Vt is just, this is another formula given, so you just replace this with the 4 out here, and you put an E, and then the negative 3 is just the number that's in front, so negative 3t. So we get, so this right here will then soon get replaced with the 75 volt. So we go down. This is the 75 volt that's active, plus the A cosine 4t, 4 from here, plus B sine 4t, times e to the negative 3 from up here, t. Now we're going to do V of 0, which is you just plug in 0 for t. Cosine is the only thing that survives. Cosine of 0 is 1. V sine of 0 is 0, so that goes away. E to the 0 is 1, so we're left with, and we got negative 18 for V0 minus, so we plug that in, 75, as I did it right here. So the only thing that's left is negative 18, 75 plus A. You move that around and you get A equals negative 93. Our V, of course, is A cosine 4t plus B b sine 4t e to the negative 3t. I of 0 is just 0. So now we do the derivative of this right here. First we do with respect with the outer, e to the negative 3t. We get negative 3a cosine 4t plus b cosine plus, now we the inside, cosine becomes negative sine, sine becomes cosine. When we do dv dt, the only things that survive are the cosines. So cosine from the first a term and the cosine from the b term. We're left with negative 3a plus 4b. So moving that around, it's 4b equals 3a. b equals 3/4 a. Plug in the a that we got, negative 93, and we get negative 69.75 for b. Now we plug all that in for this original, this right here, and we get Vt is 75 plus negative 93 for the a cosine 4t minus 69.75 sine 4t for the b e to the negative 3tv. And that's what you get for Vt when t is greater than 0.